Aya, do you hear me?
Yes, we can hear you.
Just a
We
second,
can introduce you again.
hear you.
Hello, everyone. I am Shahda, and I'll be here as a tech support during the tutorial. I want to introduce you to our tutors for the last session today, Aya, Khaled, and Essam Ammar. They are data analytics engineer and senior data engineer, and they will hold a guide to the modern data stack
Yes,
tutorial. Enjoy. Thank you.
welcome. Yes, Ammar, you can start by introducing yourself. Can you hear us?
I hear you now.
Yes. Please introduce yourself.
Okay, we already in. Okay, hi everyone. This is Essam. I'm working as a senior data engineer. Um, and what else? I have been graduated from computer science and informatics at 2015, and also I had big data diploma from Information Technology Institute at 2018, and I have been here now for around 6 years on data management field, and I'm working now as senior data engineer at Sweden. Yeah, I'm glad to be here.
Yes, thank you, Assam. My name is Aya. I'm working as a data analytics engineer, and I had the opportunity to work at Vodafone Egypt and Breakfast. And I have like 3 years or 3 years and have experience in the data field between data engineering and data analytics. And excited to have you today to start our session about analytics engineering and modern data stack.
Cool.
Okay, we can have a quick introduction for our audience. You can raise your hand and give us a brief about yourself, your education, your background. Yes, yes, Sana. We can't hear you.
I think she wrote something on the chat.
Yes. Okay. Yes, you can write here on the chat your background and your experience with the data engineering or data analytics. Okay.
Okay. I think the audience don't have, um,
Permission
so
to speak. Yes.
yeah, they don't have permission to do that. Okay,
Okay, so we can start, and if you have any question, just add it to the chat.
yeah, but yeah, just for everyone, if you could add mm, any of your expectations, or let us know where are you coming from, uh, what your profession, uh, what are the recent things that you are already working on in data fields. It will be really helpful to understand more about you. Okay, so let's start. I will start sharing the screen. Okay, as the presentation is visible.
Yes.
Okay, okay, let's start. Today we will talk about the modern data stack. What what does it mean? How you use it, and how it should be uh, beneficial to your organization. Also, we will dig deep about what are the different tools inside the modern data stack and how it's different other than the traditional data stack that we are currently use or the old system use. So first of all, let's start talking about something interesting. So it's about a butterfly uh, at the United States that had a significant migration journey. It's called monarch butterfly. They move from North of America to Mexico uh, every year, which take about more than 5,000 kilometer to uh, move from North America to Mexico, especially in the summer. And they spend the summer there in Mexico, and they return back again when the winter is finished at North of America. The interesting thing here about this butterfly is the adaptation that they follow to survive. Um, it's not about just moving from place to place through their migration journey. It's about adaptation in such weather condition. So you already know that we have a climate change recently, and it's become somehow unexpected. You have hurricanes or earthquakes there. Uh, it's totally changing over time, but still, those butterflies able to adapt to the change, those climate change, and make their migration process successfully each year. Uh, the scientists think that they use the sun, light, and the Earth's gravity to be able to reach to their destination, whatever happened with other conditions in the weather. So it wasn't like that before when the Earth was normal and the weather condition was as usual. But when things are changed, they also change it. They adapt to reach to their destination. They adapt to reach their goals. So we learn from them how to adapt whatever the change you have. You always need to have your goal and focus in your mind. So whatever you have at your organization, you have business goals, you have goals in your mind. Uh, Everyone need to adapt to reach his goals. Whatever happen, it always is changing. Everything is changing around you, but you still need to always focus in your goals. We have the same challenge there on our data world. Every day we had a lot of tools and platforms coming into picture. A lot of platforms is deprecated, and we don't know what is the best tool to use on our data transformation to drive business insights. So the key here is you need to discover a service very well and understand the potential and identify your key challenges and match from the stack that you have here which tool should fix those challenges for you. So today we will start first of all by talking about what are the current traditional data stacks that we have or old organization had. Uh, and when we understand the different components that uh, implement this traditional data stack, we will move forward to the challenges and issues that we face at this traditional data stack, and we will identify the solution in the new data stack, which will have which we name it somehow modern data stack. It's not old and modern. It's a better way for solving the problems. It's a faster way to drive insights. So we will identify the layers and different components inside the modern data stack. There are multiple stages and layer added inside the modern data stack, and we need to identify and understand each layer and what does it represent and what are the different tools that we could use to implement this phase or this layer. After that, we will end up with um, focus on the benefits that you will gain if you are going to implement this data stack in your organization. Um, from cost perspective, from insights perspective, uh, from return on investment, you need to first see what will be the impact, what are the benefits that you will gain from using and building this data stack. And finally, we will have a demo to demonstrate the idea of a new modern data stack using DBT, which is one of the tools that's really famous on transforming the data on the modern data stack. Okay, please, if you had any question, just add it to the chat, and we will take it at the end of the talk. So let's start. What are the traditional data stacks and what are the challenges that are there? So simply, um, every
Sorry,
day,
Sam, can you switch to the next slide because we still seeing the agenda?
really,
Yes.
which you should now see something else.
No.
Okay, let me stop sharing and sharing again. Um, okay, you see the slides now.
Yes. Perfect.
Yeah. Okay, so you see now traditional stack.
Yes.
Okay. Okay. How the traditional stack now is formed. If you in the last 5 years, if you are in an organization where you should have some reports or drive some insights, you will able to identify this flow. You have a set of source systems like operational databases where your app uh, uh, or transactions already reside. So you want to ingest those data from databases and build an ETL pipeline, extract the data, transform it, and clean it, and load it to the data warehouse where you will build your own analytics and build your own dashboards. And even you could enable other apps to get data from data warehouse. So everything is structured and clean inside the data warehouse, but you still have some potentials that you didn't discover. You get rid of the data, you clean and transform it from the early stages and load it directly to the data warehouse. You extract it and you transform it before loading it. So uh, those are the three layers, the three main layers inside any traditional data stack that you could use. But the challenge here is when it comes to build a new data product. And by data product, we mean a dashboard or a key, a set of key measures that you are looking for as an analyst, like what what are the average price for a product, what are the visitors rate that we receive on our websites. You are looking for a set of measures, and you need to have this insights now. But guess what? You don't have the data. So if we had a question now to you using this current traditional data stack, how many days you will need to build a new data product? How many days you will need to derive new insights? What do you think? Please add your answer in the chat. Does it will take days, month, or just an hour? Looks like the presentation is not so big.
Yes, just enable the full screen.
Full screen.
Is from the button. Yeah.
So you see here a small bar and
Yes.
keynotes. You see that?
Yes.
Okay. Screen.
Yes, from the right on the no.
Let me let me share it again. It shouldn't.
Yes.
It's speaking now.
Yes.
Okay. Just a second. How many days it will take? Give us a number, if you could, to. Okay.
Yes. Good. Good now. I think it's not days, it's about years because I worked before on building a data mart for a company and it took like 2 or 3 years to finalize it.
Yeah, but yeah, we are talking here about a big data mart, but yeah, it's really taking time. But what if you're just looking for let's say five or six measures to drive a new business idea? It's, for example, you want to build a campaign to give a gift for customers who are moving in a specific location, and they are in a specific segment level.
Yes.
So if they move in a specific location and they're segmented on A or B or C, and they are from Cairo, and the average purchase, the last money that they spent on the website was below a specific value, for example, 500 or something. You have a set of measures you are looking for to give them a gift. But the idea is now, or the challenge is, you don't have the data. You need first to go to the source, asking for the data, build an ETL, push the data to the data warehouse, and after that, calculate your measures from the data. So it will take days, but especially if you started from scratch, like you are looking for an infrastructure to run your application on it. For example, you want to run a report, or you want to get a machine where you want to deploy Spark or any transformation engine that will pull the data for you and do the transformation. So you need a machine, you need an infrastructure first. So you go to infrastructure team and ask for a machine, which will take about, I don't know, sometimes it take weeks for us to get a machine from our infrastructure team, and it should go through different layers to to move to production, because it had to go through with several security checks and vulnerability checks. Beside, we should install operating system and so on. After that, you will need to get the software, the platform that will do the processing for you. The platform that will pull the data, do the ETL, and publish the final measures to you, the final data product to you. And of course, the data. You need the data. You need to go to source system, ask for these measures, and guess what? It's not ready. They need to adjust something in their API to make your data available to be ready to be ingested to your system. So it might take months. If you are in a big enterprise, it might take, I would say, up to a year to build a start product with a list of measures. So that's how life inside the traditional data stack. You don't have everything in place. You have to start from scratch every time. Your infrastructure is on-premise, which it's really taking too much time to enable. And of course, when you are your idea is big and you are looking for more data or enrich more customers, you will ask for new machine or cluster of machines, which will take more time, and the maintenance for it will really be a headache for you. And it's not your concern. You're only looking for the data. You need infrastructure team, you need data team, you need insights team. uh, it's really overwhelming and will take too much time for you to maintain. Also, software that you are going to use, if you are talking about an organization, enterprise that used to use vendor specific software, uh, you will find a license, and you should agree in the license, and the license actually should be renewed, I don't know, every year or 5 years. And of course it will be a high expensive license. So if you imagine that you go to your manager and tell them that you have a new idea of business impact, but you consider those circumstances or challenges, you will not start it because you are not sure about the return on investment. You are going to deploy new infrastructure and buy a software license, but you are not really sure if this idea will return a big value that will be greater than or equal the money that the organization spent on this. So you will be uncertain, and there will be a lot of risks to take. And of course, the data processing, all or most of the data transformations that we had right now working on batch, and when it comes to real time, you cannot find a robust or flexible vendor platform that's flexible for you. Most of the tools that we all know about or hear about is open source. And we will talk about this later on, how the open source is really promising than the vendor softwares. And your data is still in the source and you are looking for it. But let's say that you are looking for to integrate with a new source. So your data still reside in a third API or something. So you need to go to them and create a contract to and agree on on a list of measures to get the new data for them. So your data is not on a single place. Your data is already scattered, and you have to go to every source and ask for the data to build your idea or your data product. So all these challenges that we had right now drive us to think about a new way to build our data products or a new way to drive faster insights. So before building your modern data stack, let's think about what will be the characteristics or the main advantages that it should enable us to use. First, we need faster insights, of course. When we have an idea, we need to go and gather data, discover it in a single one day. We don't need to spend weeks or months or even years to just discover the possibility of idea. Uh, it will be really great if it's low cost or the cost is managed in a way or it's lower cost than the one on premise. Also, it's scalable. If we had an idea, the idea is really promising, and we already do a proof of concept, and we know we need now to go on the whole data set. We want to run this on a big batch, millions of users. We want more machines, cluster of machines to process the data in seconds. So we want to build a cluster. It should be scalable. This even the single applications that we just wrote, just with a single clicks, it become scalable. Uh, and lastly is the flexibility. Let's imagine that we build something uh, as a when we discover a new idea, and we figure out that we need to adjust a component inside our pipeline. It should be like a plug and play. You build some components and you insert another one and still work. You don't have to reinvent the wheel and start from scratch every time. uh, we don't want to come after 5 years or something and we want to migrate again, migration over migration over migration, because the technology is really evolving. So from now we need a pipeline where we able to uh, pull a specific component from it and plug in another one, and our pipeline is still working, so we don't migrate again and again. So we will talk about now the different layers that we should have on our modern data stack. So those layers, uh, mm, we still have them a major layers and additional layers. So we'll talk about each one of them and mention a tool or example that could implement this layer with. So let's start where the data is, from the sources. The sources is where your data is. It could be structured data, unstructured data, or semi-structured data. Could be an API, could be files, could be databases, it could be social media platforms. It's a place where you're going to build, to pull or fetch data from. So your data is ready on a source, and you need now a tool or a platform to pull this data or ingest them to your storage. So inside the ingestion layer, you are going to use a platforms like Vector or Stitch. All those platforms is ready made for you. With just a click, you are going to deploy them and connect or configure them with the source, and your data is already there in just a minute. So it's ready with a specific ready connectors for a specific use cases, but you still have the flexibility to use other platforms like Spark or Kafka, it's still uh, give you the power to ingest a large volume of data and the flexibility to adjust or customize your own connectors. You could connect with files, databases, APIs. You could adjust how you are going to pull it, the amount of data, the frequency, if you are going to do high level filtration or if you are going to do some formatting. Uh, you have the both options. You have the ready-made books for you, like Bifturn, or you have a flexible platform like Spark or Kafka, where you could use any of them to pull any data that you want, and also you able to adjust and customize your own ingestion layer. So you configure this where you are going to pull the data, and you configure where you are going to land the data. So let's take it that you are pulling data from CSV files, and you're going to land it inside a BigQuery table or Google file system or S3 bucket or even a Hadoop file system. You just extract and load. You don't do any heavy transformation. It's now become ELT, not ETL. You are extracting it and loading it, and the transformation will come later. So now the data should move to the third layer, which is the data warehouse or the data storage. So here you will have um, a storage layer where you're going to land your data that you already ingested from source system, and you will start now building your own transformation. Your transformation could be made by different ways, but we have tools like DBT, which is enable you to um, bring the software engineering capabilities and the data engineering capabilities inside one single platform. So you write the query with too much flexibility. So whatever, if you are going to use BigQuery today and tomorrow you are going to move to Snowflake, you still your code will not change. If you are using Databricks and or Amazon Redshift, your query will be the same because it's using something like references and other features that enable you to drive the transformation with an easy way. And of course, give you the flexibility, like as we said, it's a plug and play. You could uh, relieve any component from them or delete any one of them and add another one. So inside the data storage layer or data warehouse, you are going to do transformation, and your transformation could be split into four different stages: landing stage, staging, warehouse, and mart layer. So just I will give you a brief about each one of them. So the landing area is where your data already stored in the first place. So it could be we could describe it as a normalized form or the raw data. Data is untouched. You just bring it and load it. After that, you build a model or a query where you going to do some high level transformation like converting data types, um, formatting some dates, and so on. After that, you have now some business logic. So you want to um, calculate some measures and KPIs that we name it like fact tables. You are going to build a mart layer where you're going to store those measures or facts inside the mart layer. And in between the staging and mart layer, you have a warehouse where you manipulate the data in a staging. or in between layer. So the warehouse layer considered the field where you have all the assets for you, where you could build a new data product based on your assets. For example, if we talk about you have a customer table, you have order items, you have say product, and you want to join all those three assets to build fact tables about what are the products that a specific customer bought on a specific day and on item level. So you join them and calculate some KPIs and build your own multi-layer. So the transformation come next after the loading. It's not like ETL. We are now talking about ELT. So your Mart is already there and it's now ready to be visualized. So you could now, yeah, we forgot one something which is really important, which is how the business will be certain that this data is really good. I mean, the data that you already transformed, the KPIs that you already generated, we need to be certain, we need to be sure that those KPIs uh, already manipulated on the right way. Like we are calculating a specific measure and it has a formula, but the developer who writes the code didn't write it well. So the data is not correct, or the data is already missed. For example, on a specific day when you run your pipeline, data is not coming and you have null values, so or missing records, so the value of the KPI is now changing, and the business is asking why we have such a value. It's not an expected behavior. Does that mean that the customer really have a change or change something, or do you have an issue inside your data pipeline? You have a missing data, your data is not qualified. So before building any reporting or deriving any insights or building any machine learning model, you need to make sure that your own marks is qualified. The data is on a good quality. That's why we had something called observability. Observability means that you are observing your data and you are doing a proactive action to prevent any data issue. If you had, for example, if you have any missing data, you pause your pipeline and give an alert where the developer come in place and see what's the issue and fix it. And once it's done, so you're going to start loading the data to the Mars. So you are proactively act on any data issue before it go to the final serving layer, before it come in front of the business, because of the business shows strong numbers, it will take a wrong decision. So we need observability before populating those data to the business or the BI layer. After we observe and make sure that our data is already qualified and in a good quality, we are now able to build a reporting or visualizing it, or even build a machine learning models or AI use cases. We are now on the fifth layer, and after that, we need to think about, okay, this is a really big and wide, and there's too many layers. It's not like simple like traditional. It has things are now in small chunks, and this actually drive a challenge of how we should connect the dots, how we manage the ingestion and transformation and the observability, how we trigger and maintain each step inside our data pipeline. That's where orchestration come into place. Orchestration means that you are looking for a tool that will manage every step inside your data pipeline, starting from extracting the data, loading it. Once it's loaded, it will trigger your own transformation logic and build the landing, staging, and mark layers. And after that, will make sure that everything is in a good quality, and we are now able to trigger our dashboards or refresh them, or trigger our own machine learning model to process the qualified just incoming data. So we are now, with orchestration, able to maintain a wide pipeline and uh, control what's going to happen inside each step. We have tools like Airflow that enables this for us. It could connect with any layer and any tool and trigger them and monitor them and do any actions based on any behavior. If an error happened, what's going to happen? If succeeded, what's going to happen? If any stage failed to complete, what's going to happen? All of the scenarios could be managed through an orchestration tools like Airflow. It's not finished yet. We had a new thing come into place, which called reverse ETL. Reverse ETL mean that we need to drive a real action on the customer. Okay, we already have a reports and machine learning model, and we already noticed that there is something here that we could get a value of, but we want this data to be ingested again to the source system. For example, if you build a segmentation model that segments the customers, we need those segments now to be used by Salesforce or Google Ads to give the customer the best experience based on those segmentation. So reverse ETL means that you are taking action or you are activating your decision with data and feed them back to the source system, because source system actually representing where the actual or a customer facing application come into place. You have Google Ads, Facebook, Stripe, Shopify, all those apps, the ones that interact with the customer. So we need those apps to enrich it with our analytics insights. So we use tools like Census to implement reverse ETL, which means you are feeding the source apps with insights to take a real action based on the data. Um, just a single note here. The main major layers here is the ingestion, data warehouse, and BI and observability. We're not always seeking for orchestration, and we're not always seeking for reverse ETL. It depends on your pipeline and how big it is and how complex it is. If it's a small pipeline or doesn't have much complexity, you just load it, load the data, and extract it, load it, and finally transform it, and you have your own reports or dashboards on it, and that's it. Sometimes you have data issue, and you are building something crucial. At that point, you need to make sure that observability is already in place and the data is in a good fit. After that, you may see that your pipeline now is now complex and you are getting data from hundreds of systems. So you want to make sure that if an issue happen in one source system will not affect the other systems. So you need something to orchestrate uh, the the full plan. So you come to orchestration. Um, if you need to take an action based on your data directly and feed it to the source, at the time you go to the reverse ETL. So the main major assets here or layers will be ingestion and data warehouse and BI. Sometimes, as I mentioned, you go to observability, orchestration, versus ETL. Okay. Just as a question, sometimes someone will ask, where is the unstructured data? Uh, just a small note here. It's going to be inside the data storage layer on phase number three. We just say it here as the data warehouse because that's where we store the structured data, but we still have the unstructured data where we store it inside file system like Hadoop file system or Google Storage or S3 bucket. We still had the data lake where it has unstructured data and structured data. The structured data we store it inside the data warehouse, but for unstructured data we store it inside file system. The the file system and data warehouse, both of them called storage layer. But here we just was focusing on the data warehouse because um, it's always related to the insights. When the insight come into place, it's always getting data from a clean data from a data warehouse. Yeah, just also a single note here on data warehouse tools. As you already noticed, it's all of them on cloud. Snowflake, Google BigQuery, Databricks, it's all in cloud. So we now moving from on-premise to cloud, and this of course will enable us to overcome the challenges that we had with the infrastructure. Now imagine that you want to uh, create a new table right now. You don't need to install BigQuery. It's already here for you. You just create an account and you have it. You want to build a Spark cluster. So you have a service inside in place. You don't have to start everything from scratch. It's a platform as a service. The platform is ready for you. You are now focusing only on the data. Also you have templates, you have components ready to ingest the data for you from source system to data warehouse. You're just going to use those templates to get the data from for example from a database to BigQuery table, or to get the data from Twitter or Facebook to BigQuery table or Google file system. You have a template and an infrastructure ready component for you to just use them as it is, with just a little set of configuration based on your use case, and with one click you enable it. So the life on cloud provide you with infrastructure as a service. uh, and after you already have the infrastructure, you had platform as a service. So if all the components now with just one click, you could go and deploy them. I don't know if you hear about Google Marketplace. This is one example of platform as a service. Inside the marketplace, you have whatever service you are looking for. You are looking for Confluent to deploy Kafka cluster, just go and click, and it's ready for you. You don't need to think about how the scalability, how many nodes that should I bring in the cluster. Even the license is already managed in place. Um, you don't need to think about the infrastructure anymore. It's already managed for you on the cloud. You need to go now to the your own use case. You are getting the data, you drive your insights. So you drive your insights faster, and this is your goal. That's why we built this from scratch. We build those layers not to add complexity, but to give you the control to plug and play any component at each stage. And also give you a platform as a service to enable you to drive insights faster and not think about any infrastructure issues or scalability issue. Okay, so now we should think about, okay, we have such of tools. It's really quite big. Inside each layer we have too many tools. For example, inside the ingestion we have Spark, Python, Stitch. Uh, Inside the orchestration we have Airflow and Register. We have inside the BI we have, inside each layer we have too many tools, and we don't know which tools that we should use. So we had the answer also. It always depends to choose which tools that you are going to use. You have to think about on different, I would say, metrics that you need to verify that this tool will have, and make sure that it's going to match and be perfect for your case. So it's not always the tool that will do everything for you. Here on Big Data World, you have too many tools. Sometimes you will find tools that will do the same thing. So you have to think many times and compare each one of them against others, and make sure that it's going to fit your case. It's not a easy exercise. It might take some time for you. Even you might need to do a proof of concept on different tools to make sure that this is a tool for you. But this question is always here and will never gone. We always think many times which tools that we should use on each stage on our modern data stack. So I'm going to just give an example here of difference between Spark and uh, Flink, and how we should use each one of them, and on which use case wh- which one of them will be the best for us. So first of all, you need to think about two things: technical consideration and non-technical considerations. For example, when we say technical considerations, we say, okay, we have a Spark, so and Flink. So what what will be the data volume that we are going to build or process? What will be the velocity of the data? What will be the rate of the data? Is it going to be 100 record per second or 100 megabyte per second? How we, okay. So you need to think about the volume and your velocity. For example, if we talk about Flink, for example, it will manage the velocity better than Spark. Both of them still able to process the data when it come to high rate data, when it's coming too much data in the same second. Both of them will process it, but Flink is much powerful when it processes the data when it comes to high rate data. It's able to process it at least once, but on Spark, it might process it multiple times if you have an issue. So here, for example, you will think about, okay, if I had an issue and the data is coming multiple time and I had to reprocess them, Spark will able to process it multiple time, which might generate duplicates. But on Flink, for example, even with the high rate data, it's able to identify that this record is already processed. We don't need no longer to reprocess it. It had a stateful pipeline which let it know if and remember if this record is already processed or not. Flink has an additional feature in this. It's more powerful in this. But sometimes you are thinking about, okay, I'm focusing on more on the batch, not streaming. So Spark give you more flexibility on batch than streaming than Flink. You might think about, okay, I need a platform that could make for me machine learning and graph analytics, and also batch streaming at the same time. At the time, Spark have a wide variety, and give you more flexibility on the languages. It give you R, Python, Java, Scala. Uh, on the other side, still Flink had some limitation on this. So after that, you think about, okay, when the issue happen, which one of them will recover, and which one will recover faster, and which one of them will recover on the right way. As I mentioned before, when we have a high velocity data or a high rate data, Flink will make sure that will process the record at least once, but Spark might process it multiple times. Both of them could recover from failure, but it depends which one of them will handle the error. So sometimes you when you have a specific requirement and you want to see action in place, you are going to do a proof of concept. Most of them on your use case was you measure your input. You have let's say 1,000 record per second, and you want to do stream processing and do a grouping for the data on interval of 5 seconds, and mm, get output of set of measures. Let's say that you have a fraud detection use case or something like that. So those are the measures or the aspects that you think about when you have such a comparison. This should be applied on whatever tools that you had. You need to think about the data volume that you are going to process. Is it does it support streaming or batch? How about the integration, the flexibility for integration? For example, Spark might have connectors to HBase, for example, but Flink doesn't. Spark have one for Python, but Flink has one for Java, and so on. So it's it's always depend on your case, and sometimes you had to do a proof of concept to make sure and get a final decision on which tool should be used in your stage layer. For non-technical consideration, this is still really important because one of things that really matter when you had an issue or a bug in your system, you go and back and ask who. You go ask the community. So as long as the community is big and there is a big company behind this platform, or a big community behind this platform, which always upgrade and make and fix those issues, you are in a good state. You always able to upgrade and use the latest version, which will has a fix. You always have the power to use the open source capabilities, because the open source is a really wide, big group, and not like the private companies. Private companies still had a limited resources on such components that they use. But the open source now is really big, and whatever you had an issue, you will find a direct support from the whole world. That's why actually all the companies now, or the vendors, uh, come in place and get tools like Spark or Flink or even Kafka, and they add it to their pipeline, and they buy it uh, and engage it inside pipeline, and bring it to you on cloud and say you could use it. It's already open source, but you will get back to us when you have that support. So they bring to you the service, and they get money for support. So instead of for example, for Google, instead of uh, doing in-house system to do stream processing, they use Apache Beam because it's open source and it's already good enough. So they bring it and add it inside their Google platform and name it or package it with a different name to let you use it. So that's the power for open source. Open source, everything now come into open source. You are able to use it. There is no license issues. You could use it as it is without any. It's for free. But when it comes to support, you are going to ask, and you sometimes you have to pay money, but sometimes not because you have a free community. When you had an issue and you search on it, you will find another one who had it before, and they had a bug, and someone go and fix it, and so on. So you are not linked or tied to the vendor. You had flexibility to use whatever tool, open source tool, because it has a big community. So when it comes to Spark and Flink, Spark had much wider community and of course support. Flink still had a big community, but not like Spark, so on. So maturity and stability. It's about if this platform is stable or not. Sometimes we see a lot of tools come into place when we see the big data, uh, but after a while of time, we saw these tools is redeprecated because there is no stability inside the tool, and when they had a bug or something, there is no big community to come and fix those bugs. So it's not stable, and there's no big support for it, and it need much more work, which will take more time. So here, for example, we had Spark, which is more stable. We had Databricks, which supports Spark so well, and make sure it has stable versions, and not like Flink doesn't. It's still stable, but not like Spark. Coastal licensing, as I mentioned, most of them is open source. Inside Spark, it's always free. Uh, and when it comes to support, you have to pay for the vendor if you are going to use Databricks or other companies that provide support for Spark. For Flink, you could buy the open source and commercial one. They have the Flink platform has a license, a commercial license for it. And finally, integration with existing infrastructure. When it comes to Spark or Flink, which one of them provide you with flexibility to connect for various systems, database or files or APIs or whatever source systems that you are looking for? As I mentioned, sometimes you will find a connector inside Spark, not there in Flink, and vice versa. Flink might have a specific connector in a specific language in Java, for example, but you are looking for a connector on Python, which you are going to customize or something. So, in brief, you have this general guidelines to use uh, when you decide which one you should use. You should do it for, let's say, Spark and Kafka, for example, and you see which one of them will fit for you. If you have a volume of data, which one of them support batching and streaming at the same time, if you have an AI machine learning requirement or not, which one have a big supporter community, what are the languages that they support, all those considerations or guidelines, you could take it as a reference when it comes to compare different tools. Okay, so we come to the last part here, which is the benefits of modern data stack. So, okay, it's a really quite uh, good good staging of layers, which really drive um, good impact, and we already see that it's going to drive us what we are going to looking for. The cloud is in place. everything is ready for you. You are focusing on your data. Um, so we will focus now on those key benefits one by one to tell you all the details about it. So we'll start by the real-time analytics. On the traditional side, as I mentioned, on real-time analytics, you cannot use the same platform that you are using from the vendor for batch. When it comes to streaming, you will find so many challenges, and to overcome those challenges, you will find that the open source is really fast and already solved those issues, and they are 3 or 4 steps ahead on the open source community when it comes to tools like Spark or Flink or any open source for streaming analytics. You will find that they really resolve the issues faster than the vendor software. So on modern data stack, when you are looking for uh, faster transformation, you will find the support tool for you. So you will drive a faster analytics. Of course, the cost now is different. You don't have a data center that you had to manage. It will be on cloud. So you have different ways to pay there. You might pay as you go. You have different bundle or plans that match your your use case. If you have something to do BOC for it, or a new idea to bring a new data product, you should just go and try it and shut down it once you already finished, and that's it. You don't have to always pay all the time. It's not like on-premise. You on-premise, you bring the machine and you try something, but you still running the machine. You have it. It's already on your stack, and you already bought the machine. But on cloud, once you want to try something, you will turn on the machine. Once you already done and you verify your idea, you will turn it off, and it's no longer uh, uh, your case. It's now managed by the provider. You don't have to worry about anything else. Just a pay as you go. The data quality now is come with I would say a clear point of view. So earlier when we had the on-premise system or the traditional data warehouses, we had a lot of issues to make sure that the data, all the data in place, in one place, and also the data is already qualified before landing it to the data warehouse or before driving in insights from it. Using the modern tools inside the modern data stack like dbt or Databricks inside Google Cloud, all these tools provide the observability, which, as we mentioned, observability mean that we already do a proactive action before loading the data. We first check the data is matched our expectation, and if everything is okay, we are going to land it or transform it and drive insights from it. We cannot drive false insights. We cannot let the business take a wrong decision based on any issues or discrepancies inside the data. We need to make sure that the data is already qualified. So inside the modern data stack, you have much flexibility and too many tools like dbt and Databricks and others that enable you to proactively think about and do your own measures to make sure that your data is already qualified. Of course, you are in cloud. You don't have to think about how many machines should I think about, or what's going to happen if we scale to up to 1,000 machine or something. You just run your query, and it's going to promote to set of machines and do the calculation for you and returns the output. You don't need to think about how many machines or cluster machines that BigQuery will use, for example. You don't need to think about should I buy or install the services on each machine that I bring to my cluster. You just say that I need 4, 6, or 10 or 1,000 machines, and that's it. And it's already deployed for you, manage it, auto scaled. You don't need to think about any scalability issue. It's totally managed by the cloud. And of course, you remember the butterfly, how it was adapting when we had the climate change. They able to identify their goals, and they didn't care about the climate change, or they adapt and learn how to adapt to reach their goals. Here we had the same feature inside our modern data stack. At any point of time, if we need to, if any tools or any components that we use inside any layer, if we had any issue inside this component and we need to replace it, we could easily plug and play another component from the market, and which is still able to integrate with the whole pipeline. We don't need to uh, revamp everything or migrate again to a new platform. Everything is already integrated with easy way. For example, inside DBT, when DBT is a transformation platform where you bring your data from, for example, BigQuery, and do your own transformation on it. Let's say you are going to replace BigQuery with other platform, it's still going to work. You just going to uh, um, install the provider or the Redshift, for example, on AWS, and that's it, because it's using references, and references refer the the tables itself. So whatever you change the tables, you change the dataset names, you change the vendor data warehouse, you're still good enough, and you don't have to revamp everything and start from scratch. It's able to flexibly adapt to any change happen during the revolution of data stack. And finally, this is really important. It's imagine that we already have the data and everything in place now, but the data is not visible, or it's hard to share with the business side. If the business need to discover data for sales or data for charges or customer segmentation, they don't need to go to BigQuery. They are not so technical. They want to uh, a user interface where they search with key labels like customer ID or customer loyalty points. Those business metrics will be added inside a catalog, and this catalog will be connected to the data itself. So inside the modern data stack, we have catalog, and inside this catalog you could use and write any text to search on data assets with easy way. You just write it and you will bring it into your face without no need to go technically and search on data sets or tables inside BigQuery. So the data is democratized and shared with an easy way. You don't have to ask for permissions and spend days to get the permission to access the data. With just a click, you are asking for access, and you got it. It's just a single reference to one data owner who manages the access for it. But you don't need to go through 5 or 6 people to get the permission to get access. Inside the catalog, you have all things that you need with ease. So, yep, time demo. But
Yes.
before demo, we don't know if you have any question. We could take it now, I think.
I think you can add your question to the Q&A part. We can check it and can give you an answer. Because we have 10 minutes left, so I think we need to start the demo. It will be a quick one.
Okay, I think we could start, and if anyone had a question, he could write it and we could answer it as the end.
Yes. Can you disable your screen, because I'm trying to share my screen, but
Mm,
thank
I don't share. I already stopped sharing.
yes. Okay, it will be a quick demo to show you how to connect to DBT. DBT is a tool from the modern data stack used for data transformation. Okay,
Yeah, I think we are seeing your screen now.
yes, DBT, right?
Yes.
Good. To start working with DBT, you need the account on one of the cloud provider, AWS, Redshift, or Google BigQuery or Snowflake. And you need to have an account on GitHub and create a free account on DBT. You can follow the documentation. It's a normal setup. You just need to add your uh, data warehouse account and your GitHub account and set up a project. It's a free, and you can access BigQuery Sandbox for free. So the idea behind DBT is to build the transformation layer to build your data warehouse tables and data mart tables. You can write normal SQL query, but the key feature of DBT to have a version control connected to your GitHub to track any change or on your queries. And the second thing, to use DBT special keyword. For example, you need to start your project by building the source file. The source file is a method to list or your data warehouse raw data. So, for example, we have on BigQuery three tables, one called customers and one called orders and one called payment. I'll show you the tables. Okay. Can you see BigQuery now? Okay. I start to build the table from BigQuery free data sets. I build the customer raw data and order raw data and payment. It's a small table, so you just need to run it. It's a free of charge. You will not be charging for anything. So the customer data is raw data without any transformation. We have customer ID, first name and last name, orders. It's a simple table for order ID and user ID and status of the orders. And payment for the information related to the payment. This is the raw data. And the next step to connect to DBT and start the transformation. So on DBT, I need to list all the source tables we just see on BigQuery, and to reference the database name because it's important to add it to DBT model. And the second step to start the transformation, for me, I started with something called draw to do minimum transformation on the data. As you can see from here, it's a normal SQL query, but with a special keyword called source to build the data lineage. This way you can track the source table and the transformed table and the final table. Without this keyword, if you select direct from the customer table on BigQuery, you will not be able to build the lineage and you will lose the main feature of DBT. So it's important to use DBT keywords. So this way we can build the table on DBT. From here, it will run the query and build the table on BigQuery. And you can check the schema and table name from here. And it will be the same on BigQuery. The same for the row order, minimum transformation and selecting from the order table, and the same for the payment table. The idea here to do the minimum transformation on the table, renaming or changing the data type, And the second step to build the fact table, just simple select from the models. And the second keyword here is called ref. It's a reference to your DBT model. The difference between ref and source, the source reference the table as it on your data warehouse, and ref reference the model you just built on DBT or using DBT. And if we check the lineage, you can see the full pipeline starting from the source table as it coming from your source using any of the ATL tools. And the second part to build a transformation layer or doing some data cleaning and transformation. And the third one to build your fact table. And this way you can track all the changes and all the table used on the transformation. And with the version control, if you are familiar with Git and GitHub concept, you can see all the changes and you can do the commit and pull request or revert anything if you need to change something or revert to a different version. And this way, it's easy for you and your data team to build a huge data transformation with a simple steps and the documentation. I'll show you the documentation part. So with DBT, you can build a full documentation. So can you see the documentation? Because we don't have many tables here, but if you have, you can see the source data and the models. And from here, you can see the lineage of everything. If you need to select a specific table or you add a tag to your models or by project. So with DBT, you can have a version control, a data lineage, a documentation, and a quality checks because you can add some tests on the data quality to add some condition to make sure the data is correct and matching your expectation. And that's all for this demo. So we can back to the questions. I hope it was
I
clear and simple.
Yes, it is. I just added a comment on the chat. I see Sana was saying that 4 and 6 are both unclear in this sequence, especially sixth stage.
I think
Um,
she was mentioning Airflow and Dexter. It's an orchestration tool. After building the whole pipeline and deploying the job, you just need to orchestrate which part should be first and which should be second. Just orchestration to the pipeline. For example, if you're getting the data from maybe SQL Server or API, and the second step should be the transformation on dbt, and just this way you can manage the flow of your pipeline.
yeah, the idea about the orchestration is sometimes it could be just as simple as a cron tab that triggers something on a specific time, and that's it. But when your data pipeline is complex and had many stages inside it, as we mentioned inside the data warehouse, for example, you have staging, you have mart layer, you have staging layer, landing layer. You are doing mini transformation inside different stage, and you are getting data from a source. So when it comes to a complex pipeline, uh, and you would like to connect all of them in a whole single managed flow, this could be managed through something like Airflow. So it gives you the flexibility to do what when an issue happen inside, let's say you're loading data to a table and then failure happen, you might need to retry, or you would like to trigger a failure pipeline, or a third pipeline that you already created for handling the failure, or you would like to trigger an alert or something. So it give you much more features to control what's going to happen when you have anything in your complex pipeline. Again, we mean complex pipeline, uh, which had many stages, and it's hard for you to manage all of them. So I could give an example when we need to build sales, for example, report, and this sales report should come from customer, come from customer fulfillment, should come from sales. It's three different sources, and each one of them has own build pipeline. So to get the final report, you need to make sure that the first pipeline is run and finished successfully. And next, you are going to trigger second one in a sequence. Third, you will trigger third one for sales. And after that, you will have a look on the measures and make sure that they are in a good quality. So you are going to run a force pipeline to do a quality checks, and finally you will trigger your own reports. So y- through the orchestration, you will manage around 4 or 5 separate pipelines to get a final report up and running.
Okay, I hope the session was clear for you and simple. And if you have any question, I think the only way now to reach out us on LinkedIn. And if we have 1 or 2 minutes left, we would be happy to listen to your feedback. So if you have any comment, you can write it on the chat.
Yes, please.
Yes. The only thing to add is the modern data stack is about how to switch between the tools and the role inside your data team, because everyone now can be able to retrieve the data and work on the transformation and BR layer. Because in the old data stack, you have your backend team handling the pulling data from the data source and manage the data sources, and data engineering team to handle the ingestion and design the data pipeline, and your BI team to handle the visualization part. But now with the new tools, anyone from your data team can work on the transformation part or pulling data from the data source and connecting into the visualization. So it's now easier for your data team to collaborate because the tool abstracts the complex concepts, and with the user-friendly uh, interface, you can work easily with your pipeline and design.
Yeah, I think time is up. Thank you,
Yes.
everyone. Thank you, Aya.
Thank you, Aya and Assam, and thank you for everyone for attending the tutorial and being with us. See you tomorrow, inshallah, at the EUI at 9:30. Thank you.
Thank you.
Bye.
Bye.